Alright, hello year 11s. What I'm going to do is exercise 3F. I decided to go through the different ways of sketching the graphs. I know we talked about it in class, but I'm just going to go through the examples in case you have some issues with them. Yeah? So let's have a look. For the first one that's up here, what we have is a turning point form. So before you sketch, you always look at what kind of form you have. And the tip that I usually give is if you get two x's, so you can see here there's only one x here, then it's likely to only be a turning point form. So for example, if I give you, that's a turning point form. There's only one x. If I gave you, that's not a turning point form. There are two x's. If I gave you, that's not a turning point form because it has two x's. If I gave you, that's a turning point form because it only has one x. Okay, so in our case here, this is a turning point form. Why is it important to know if it's a turning point form or not? Is because you can then read the equation. So from exercise 3D, okay, that's how you know, and there's a whole PowerPoint on that one as well to read the equation. In our case, we can read the equation and see, oh, that's a +3. Okay, now hopefully you remember from my notes, this will tell you up or down. In our case, because it's +3, it's up 3. We see there's a negative. That means it's a frown. It's a negative. A is the value. A is currently 3. Okay, and that means it's narrow. But because it's negative, it's a frown and a narrow. Whereas if you look at x minus 4, remember the technique I taught in class, I said if you let what you're squaring, see what we're squaring here, which I'll highlight again, this is what we're squaring. Because we're squaring the x minus 4, the technique I taught in class was I said, let that equal to 0 and then solve for x. That will tell you left or right. So if I solve for x right now, it goes to the right by 4. Therefore, you can say it's +4, which means right by 4. So if you put it all together, okay, if we were to roughly sketch this, we can see a couple of things that go. It starts from the center, which is 0, 0. It goes up by 3. 1, 2, 3. It goes up by 3. Okay. And then it goes to the right by 4. So 1, 2, 3, 4. This is where our turning point is. But when reading it, you can already tell what the turning point is. Okay. You know it's at 4. Goes across 4 to the right by 4. Up by 3. Okay. Now the only thing we need is we got a turning point. We need x-intercept and y-intercept. Now, y-intercept is one of the easiest ones to do first. So what I'm going to do is I'm just going to rub all of this off. Okay, and then we're going to go now find the y-intercept. Okay, so if you were to find the y-intercept, then later you'll find the x-intercept. Y-intercept, you let x equal to 0. Okay, so you got let x equal to 0 to find out the y-intercept. So remember the y-intercept, you're letting x equal to 0 and you're finding y. So let's do it. I'm going to go, okay, so according to the equation, y equals -3 times 0 minus 4 squared plus 3. That now gives you -3, -4 squared plus 3, and that becomes -3 times -4 squared is 16 plus 3. And, whoops, -3 times 16, what is that? Let's go, that's what, I think -48. Yes, it is, -48 plus 3. Okay, and -48 plus 3 is -45. So what does that tell me? It just tells me that the y value is -45 when x is 0. So I know in terms of my y-intercept, it's at 0, -45. Okay, so if I think about it, it's a frown. Remember, this graph was a frown because they had the negative. From the turning point, I know it has to cross through something like that. Okay, I'm just going to draw a bit more properly to cross through there. Okay. And the only thing I need now are my x-intercepts. Those are my x-intercepts. So let's work out our x-intercepts. X-intercept, on the other hand, you need x-intercept is when y is equal to 0. So you're going to let y equal to 0 in this case, and you now apply it, and you say 0 is equal to -3 bracket x minus 4 squared plus 3. From here, it's all inverse operations. The nice thing about turning point is you only have one x value. So you can use inverse operations to solve this. You can say, alright, well, let's go backwards. BODMAS, you go backwards, right? So let's have a look. You got plus 3, the opposite of plus 3 is minus 3. So if I minus 3 on both sides, 3 minus 3 cancels out. You get -3 equals to -3 bracket x minus 4 all squared. That's a times -3, so we say divide by -3 on both sides. You get now divide by -3, divide by -3, cancels out to be 1, and this also cancels out to be 1. So you get -1, oh sorry, +1, because two negatives make a positive, is equal to x minus 4 all squared. To get rid of the square, inverse of squaring, we know it's square root. Okay, and then follow on with the next step. So we say squaring, square root cancels out. Square root of +1 is plus -1. Because remember, when you square root, you get a plus and a minus answer. And we're almost done. So finally, that's a -4 here. So we're going to say add 4 on both sides. So what you get is add 4 on both sides. Okay, because it's +4. So okay, +4, +4. Yeah. Now, our answer is you can have x is equal to either 4 plus the 1, or you can have x where is equal to 4 minus the 1. In that case, we've got 5, or we can have 3. Okay, so that means the turning point, remember, was at 4, 3. This x-intercept has to be 3, so it's at 3, 0. Whereas the other one was at 5, 0. So there you go, you got our graph. We've got y-intercept, x-intercept, turning point. But that was easy and nice to see the shape because we can read the turning point form. Okay? Let's try another one. Let's try this one. So first step, ask yourself, what kind of form do I have? Clearly I've got two x values or x variables, and so I know it's not a turning point form. This is a general form. The nice thing about this one is that you can clearly off the bat factorize it. Okay, so if I have a look at this, I can say, well, if it's a general form, remember you have to factorize it, but in this case it's easier to factorize because I can take out the common factor of x. That gives me x minus 4. Yeah, taking out x as a common factor. Nice thing about this is now we can answer the questions. What are we trying to find? Y-intercept, x-intercept, turning point, right? Let's start off with y-intercept. Y-intercept's the easiest one to find. So x is always 0. We're going to try to find y. Y is equal to x, which is 0, times 0 minus 4. And that gives me 0. Okay, so what does that mean? That just means when x is 0, y is 0. Now, next thing I need is I need x-intercept. Now, x-intercept occurs when y equals equal to 0. So in our case, when x is there, y is equal to 0. So let's apply it. 0 equals to x multiplied to x minus 4. Now you see, this is why we've been learning to factorize, because here you can use null factor law, exercise 3c. Yeah, so if you have a look, you either have this number multiplied to this number and they equal to 0. So that means one of them has to be 0. It could be x equal to 0 in this case here, or it could be x minus 4 equals 0 in this case here. So if it was x minus 4 to equal to 0, then we know that x has to be 4, because I'm adding 4 on both sides to remove the 4's and get x by itself. Yeah. So what does that tell me? Now I got two coordinates. I've got 0, 0, and I've also got 4 when y is 0. Those are my x-intercepts and y-intercepts. Now, when you're sketching, remember you need three things. You got y-intercept, x-intercept, you also need turning point. So our turning point, remember I said, turning point has an x and a y coordinate, and you know that the turning point is in the middle. But conveniently, think about it, the x-intercept is at 0, 0, so it's at 0, and it's at 4, 0. So if you want to know where the middle is, where's the middle between 0 and 4? It's obviously 2, but the technique I taught you to figure out where the middle was, I said to find out where the x coordinate middle, which we call the axis of symmetry, this is called the axis of symmetry, because it tells you where the middle is, well then you find the average. 0 plus 4 divided by 2. See, 0 is your x coordinate plus 4 divided by 2 will tell you where it should be, and that gives you 4 on 2, which is 2. So that tells me the middle of this graph, so I'm just drawing it out so you can see, has to be at 2. What I don't know is, I don't know where the coordinate of the turning point is, because I only found the x. I need to find the y coordinate. So now that I know the x coordinate is equal to 2, to find the y coordinate, I've got my equation over here. It says y equals x squared minus 4x. So alright, I'm like x squared, which is 2 squared, minus 4 times the 2. That gives me 4 minus 8, negative 4. So now I know, therefore turning point is at 2, y value is negative 4. Okay, so now I can plot them all together. I can say, alright, so I've got the x-intercepts, turning point, which we knew was at negative 4, so it's right over here, 2, negative 4, and the y-intercept was at 0, 0, and the x-intercept was at 0, 0, so we just happen to have both x-intercept and y-intercept at the same spot. So now we can put it all together, we can connect the dots, and notice the value that's multiplied to x squared right now is a positive 1, so it's positive. Because it's positive, it's a smiley face. Okay, but even if you didn't know that, if you joined the dots, then it would have turned out to be a smiley face anyway. You couldn't have done a frown because the turning point's on the bottom. Okay, let's try another one. Okay, so let's have a look at this one. Is this a turning point form, or is it a general form? Look at the number of x variables. In our case, we got 1. So it's a turning point form. So if it's a turning point form, you can read from it from exercise 3D. Okay. So again, you got to practice reading it. Read my notes on this. Read the PowerPoint as well. I try to describe how to read left and right, up and down. Yeah. So in this case here, another way of looking at this is you've got y equals, what are you squaring? You're squaring the x. Okay, and what do you have? You've got a minus 9. So right now, I know there's no number in front of the brackets, but naturally, it must be a positive 1. We just don't write it. So if you read it, positive 1 implies that it's a smiley face, because it's positive. The minus 9 is one of the easiest ones to find. It means down 9. Okay, and then if you want to know if it moves left or right, remember I said whatever you're squaring, let it equal to 0. So in our case, let it equal to 0, and then solve for x. But in our case here, if you solve for x, x equals 0. So what does that mean? It means it doesn't move left or right. So it's right at the center. So if I were to just quickly, roughly sketch this, it's pretty easy because it starts at 0, that's the center, goes down by 9, so down by 9, so I just go all the way down a 9. Sorry, I sneezed there. Minus 9, so that's where it's gone down, but it doesn't move left or right, so that's where my turning point is. It's at 0, negative 9. And then, it's a positive graph, so I'm just going to draw my positive graph. There we go. That's the shape. The only thing I'm missing right now, because I already got the y-intercept, because it goes down by 9, and then it didn't move left or right, so the y-intercept is the turning point. Yeah? Based on reading the graph. And now, you just need to find your x-intercept. But let's say you weren't sure, you can still find the y-intercept. You see, you can say y-intercept has to be when x is equal to 0, and you want to find y. So according to our equation, let x equal to 0, and you find out it ends up being what I just told you. So, but it just saves you the work if you can read the equation. Now to do the x-intercept, you want to let y equal to 0. So in our case here, we've got 0 equals to x squared minus 9. Okay, and yes, you can factorize this, or you can do inverse operations. Okay, so I like you to factorize it so that you practice your factorizing skills. Like it's x minus 3, x plus 3, using difference of perfect squares. Okay, and then you're using null factor law now. So you've got this multiplied to this should equal to 0. So that means one of them has to be 0. So it could be x minus 3 equals 0. And you can see adding 3 on both sides, x equals 3. Or it could be x plus 3 equals 0. And then minus 3 on both sides, x equals negative 3. Okay? Using null factor law. So what does that tell me? I means that when x is 3, y is 0. When x is negative 3, y is 0. Because that's what we did. We said y is equal to 0. So now I know this must be negative 3, and this must be 3. Okay? Alternatively, like I said, if you wanted to do inverse operations, so you had 0 equals x squared minus 9, and you didn't want to factorize it, then yeah, what you can do here is you can say, since that's a minus 9, add 9 on both sides. 9 minus 9 cancels out, so you get 9 equals to x squared, and then you can see that you can square root both sides, so square root of 9 equals to x, okay, because I'm squaring both sides, that cancels out. And then we know square root of 9 is 3, but remember when you square root, it has to have a plus and a minus answer. So that gives you the same thing as well. You get positive and negative 3. The reason why I emphasize factorizing is, again, for you to revise exercise 3b. But on top of that, you can't always use this technique. See, for example, the previous one, you couldn't have done that. You've got y equals to x squared minus 4x. You couldn't just say, all right, I'm going to plus 4x on both sides, if that equals to 0, sorry. Finding y-intercept. If you plus 4x on both sides, then you get 4x equals x squared, and you land into a problem. So you get into a problem here. You can't solve it because you got 2 x variables. Whereas why can you do it with this one? Because turning point form only has 1 x variable, and that's nice. You can solve it when it only has 1 x variable. If you go back to this example, same thing. Why could we do inverse operations here without factorizing? Is because, again, you only got 1 x variable. It's possible to do inverse operations to solve. Okay? So when you have 2, you just have to factorize. Okay? So like this one, for example, this next and the last example, you've got now a general form. Okay? So this one has the x's, and it also has a constant. And what you can see is when you have 2 x's, you're going to have to factorize it. So here, first step is to factorize, and I'm going to use the cross method. And hopefully at this point you can factorize quicker. And I know the answer would have to be 3 times the 4, but I want a positive x. It has to be a positive 4 minus x. Okay, so I've factorized it using cross method. And again, you got to revise how to do cross method if you've forgotten. Go to exercise 3b to have a look at it again. You got to practice these. So again, same thing. You got to find the 3 things. Y-intercept is when x equals 0. So there we go. And we're going to solve for it. So y is equal to, let x equal to 0, 0 plus 4 times 0 minus 3. And here we go. We've got 4 times negative 3 is negative 12. Which makes sense because, you know, that looks like it's going to have a y-intercept. If you let this equal to 0 and you let this equal to 0, then of course that's your y-intercept. Yeah, 0 plus 0 minus 12. So now you know it's 0 minus 12 as your y-intercept. The next thing you need is your x-intercept. X-intercept, you're going to let y equal to 0. Okay, so you're going to let y equal to 0. In our case here, 0 is equal to, because you let y equal to 0 here, 0 is equal to x plus 4 times x minus 3. Okay, and then from here, it's an null factor law again, exercise 3c. So everything goes back to the first few exercises, A, B, C, D, and E. E is later on, but A, B, C, D, E allows you to have all the skills to sketch in exercise 3F, which is what this is, yeah? So I'm using null factor law 3C, two numbers multiplied to each other equals, and it equals to 0, so one of it has to be 0. So I'm going to go with x plus 4. If that was equal to 0, minus 4 on both sides, x equals negative 4. This is x minus 3, so you got x minus 3. If it was to equal to 0, then add 3 on both sides, and x equals 3. Okay. There we go. And now, putting them all together, okay, you've got now y-intercept, which you know is at 0 and negative 2. You got x-intercept negative 4 and 3, and you now need a turning point, right? Now, turning point, remember I told you it has an x and a y coordinate. You can find the x coordinate because that's the axis of symmetry. The axis of symmetry is the middle of negative 4 and 3. How do you find the middle? Find the average. Negative 4 plus 3 divided by 2 is the average. Yeah? So this will tell you the x coordinate. Negative 4 plus 3 is negative 1 over 2. Okay, now you only found x. So you now only know it's that negative half, but you don't know what y is. So the only way to find y is you substitute x back in. So think about it. You've got y is equal to this entire equation. I personally like to just sub it into the factorized form. So you got negative half plus 4 and negative half minus 3. Yeah, hopefully your fractions are okay. At this point you can sort of add and subtract them. For me, I know that this is now 8 minus 1, so 7 on 2 times, that's 3.5, yeah? 4 take away half is 3.5, 7 on 2, multiplied 2, this is negative 7 on 2, okay? So it's all about working with your fractions here. I know a lot of students don't like it, but you just got to work with it, okay? You got to learn it. You started back in primary school in 3 and 4, you had to know how to do this. But in case you didn't, how did I do this quickly? One of the techniques that is taught in year 8 is that 3 is the same thing as writing 3 out of 1. Whoops. And then you can do cross method. So you do 2 times the negative 3, and then that now gives you negative 1 all over 2, because 2 times 1 is 2. 2 times negative 3 is minus 6, and 1 times negative 1 is minus 1. Okay, so this is what you get, and what you can see is negative 1 minus 6 minus 7 on 2. That's how I did it. Okay, now over time, all I really do, when I see something like this, what I do is I just do 2 times negative 3 and then minus 1. Yeah, because 2 times negative 3 is minus 6, and that's a minus 1 there, so minus 6 minus 1 is minus 7 over that denominator there, which is 2. And that's how I did it for this one as well. I said negative half plus 4. What I did was I did 2 times 4, which is 8, and then that's a minus 1, so 8 minus 1 is 7 on 2. Okay, that's just a quick revision of fractions, but you are required to know how to do it. So if you're struggling with it, practice it. So this gives you what? Negative 49 on 4. Okay, so that means I now know the y coordinate is negative 49 on 4, which tells me now it's negative half, and that's what? Negative 12 and a quarter. I'm just changing it to mixed fractions so you know where it is. Okay, there we go. Now if I were to answer the question, if we were to sketch the graph, same thing, we got your y-intercept, which is at 0, negative 12. So 0, negative 12. We've got our x plus 4, x equals negative 4 and x equals 3. So negative 4 and 3. So negative 4 and 3. Let's say 3 is here. Okay. And we know the turning point is at negative half. So let's say negative half all the way down. It's just 12 and a quarter, negative 12 and a quarter. So maybe negative 12 and a quarter is about here. So there we go. That's negative 1/2 and negative 12 and a quarter. Okay, that's my turning point. So if I put it all together, whoops. Okay, I'm drawing on a tablet, so it's terrible. But there we go. Something like that. Okay, so again, if you just connect the dots, you'll find out whether it's positive or negative, but you can see This is a positive, it's the value in front of x squared. It's always what you're squaring, and because it's positive, you know it's a smiley face type of shape. Okay, so that summarizes all the types of graphs that you can potentially get. So I'll just quickly summarize them. You can get a turning point form, yeah? Exercise 3D, turning point form, you gotta learn how to read it, yeah? And how do you know? Because it's only got one x value there. You get another turning point form that looks like this. Has only one x value there, or x variable, sorry, not value, variable, and that's a turning point form, so you read from it. Again, exercise 3D. Then you might get a general form, but this is actually an easier one because it only has x's, it doesn't have a constant, meaning the number at the end of it. See, it's just x squared minus 4x, there's no number here. So that one is a general form, and you always want to factorize it, but the nice thing is they always have a factor of x. Whereas this one, this is your full general form. It has the x's, which is the two x variables, and it has a constant. That's where you had to learn how to factorize, and I emphasize so much on your cross method in exercise 3b so that you can get this step. Whoops, this step. See, that step then allows you to solve when you do null factor law down here. Okay, that's what the quizzes were all about. So please, hopefully you've been practicing, and up to this step, if you're watching this video, it makes a lot of sense on why all the skills are applied. Okay, so if I were just to quickly summarize the skills that you should be knowing right now is, I'm just thinking, I'll do it in black. Factorizing, this step here, this is exercise 3b. Okay, one step, this is substitution, so you can think of it as exercise 3a, just learning how to substitute x values. Okay, the next one, x-intercept, this is null factor law because you're letting it equal to 0. Okay, so exercise 3c. Okay, turning point, this is exercise 3f really. Okay, because you know it's the middle. Alright, so that's 3f, finding the middle, average, sub in to find the y value. And then, where's d coming from? This is exercise 3d, reading the turning point form, exercise 3d. Okay, the only thing you're missing right now is exercise 3e, which is completing the square. When do you use that? It's when you can't factorize this using the cross method. That's when you use completing the square to turn it into, turn it into a turning point form. That's the point of it. Okay, and when you have turning point form, you can do exercise 3D. So that's why it's so important that you have to be able to do 3A to 3E in order to do 3F. That's why I'm going to be checking your homework every Wednesday now, and I'll be double checking that you are keeping up, because without those exercises you can't move forward. Yeah. Alright, thanks for watching, and that's it for exercise 3F. Okay, so if you have a look at the questions, you see they're all, whoops, sorry, that's 3E. All the questions, they're just simply a variation of those kind of equations. Where's 3F? Here we go, 3F. So if you have a look at all four of them, I mean all four of the types of equations, you've got turning point form. See, that only has one x. This is not a turning point form, general form. So you got to factorize this and then solve it. You got your turning point form again, turning point form again, turning point form again. You know, and all of this is your general form. So all the four examples I did should allow you to do these type of questions. Okay. At the end of the day, you're just really trying to find the three things: y-intercept, x-intercept, turning point. You can do that well. You can do 3F well. Okay. Thanks for watching, and I'll see you in class today.